Alrighty everyone, so we are now on day 4 of our triangle congruence unit. We're starting on SAS and HL today. You might be able to guess what some of those letters mean based on our previous lessons. Hopefully those have been going well for you. Reminder that if you're struggling with some of it, do not just sit and drown in your own head. Ask a teacher for help. Go back and view the lessons. What's nice about the videos is you can rewind what it says. You can go back and figure out which part you really don't understand, or maybe try and hear it again for a second time to get a better understanding of it. There are plenty of math teachers in the building. There's plenty of people you can ask for help, so please do so. I know it's not the easiest unit, but you gotta make the most of it and do your part to get it figured out. Alright, so we're starting on this stuff today. We're talking about proofs again, focusing on our reasoning skills, our logic. Okay, we're going to work on proving something in math so that we can prove things better in our lives outside of math. You got to be able to prove stuff to make sense to other people. You can't just say what you want. You got to have opinions that are backed up by good reasons, just like with math. So a big part of today is this definition, included angle. Included means in between. All right, so this angle is the one between those two pencils, that drawing that you got. And SAS stands for side, angle, side. So the first time we're using angles in our shortcuts. Before we had SSS, so it was all sides. Now we're using an angle in between. So two sides and the included angle, so the angle between those two sides, of one triangle are congruent to two sides, and the included angle of a second triangle, and they're congruent, hence SAS. So if this side is congruent to this side, and these two sides are congruent, so that would be BA is congruent to ED, and if AC is congruent to DF, then the angle between them, and it has to be the angle between them, in other words, this one right here and this one right here, those are the ones that are congruent. I cannot say angle B is equal to angle E and get it right. Okay, that would be ASS, which if you spell that out in your head, makes a curse word. We don't want the curse word, not only because it's just rude, and second, because it doesn't actually work out. Okay, I can prove you the whole theorem, but just trust me, ASS does not work in triangles. It is SAS for a reason, so please, please, please be careful about that. Alright? And then, of course, our congruent statement as normal. So go ahead and pause and fill that in as you need to. Alright, so first example. Again, we're going to focus on SAS, so obviously we kind of know what we're looking for. We should always check to see what do we have and what can we look for. Alright, so it tells us that BC is congruent to DA in the given. That's marked in our picture, so we don't need to do anything with that. That's already done. So I have one side given to me that's equal on both. And then it tells me BC, and it's got these symbols right here. That means parallel. And that's also marked by these handy dandy little arrows. Those mean parallel as well. BC is parallel to AD. Now there should be kind of big flashing lights going off on your head. Whenever you see parallel, you should probably guess that angles are congruent somewhere in there. Okay, remember when we learned alternate interior and exterior and corresponding and all those fun angles that you guys love so very much? Well, they're coming back to haunt you. We told you they would come back. So think back to those things. You might even get out your handy dandy flashcard that you have. And let's extend our lines so that we have those nice big bold parallel lines. And let's figure out where the heck these congruent angles are. Okay, now I want to be strategic about them. We're looking for congruent triangles. That means I'm trying to find a congruent angle in each one of my triangles. I don't want to pick one, or I don't want to pick two congruent angles in the same triangle, because that doesn't do me any good. Alright? So if I cut through my parallel lines like so, and I'm even going to actually get rid of this a little bit just to sort of help you see. Don't erase your sheet. Okay, I'm just showing you. If I kind of erase that out, it sort of helps you see your transversal. Now, in your head, what angle angles are those? See if you can think about in your brain. All right. So BCA is actually congruent to angle CAD. That's the red ones I just marked. Okay? And if I erase my picture, it's still there. Okay? And they are congruent because they are alternate interior angles. They're in between the two parallel lines, right here and right here. And they're on opposite sides. That one's on the bottom. That one's on the left, that one's on the right. They're alternate interiors, so they are congruent. So now I have a side, I have an angle. SAS requires me to have one more side, and it has to go in order. Okay? I've already gotten side, angle. Now I need the other side. Okay, well, what's the side that would make this angle in between the two sides? Okay, well, it's this one right here. Same thing in this one, it would be this part. Okay, well that middle side is CA, if you can see through all the scribbles I've written over it. On yours, I'm sure you can see it. And it is the same in both because it overlaps, and since we do this every single day for the past couple days, hopefully you remember by now that it is the reflexive property. Anytime you say that something is equal to itself, it is the reflexive property. Now I've got a side that was already done. I've got an angle that I figured out, a side that we figured out. Now we know the whole thing is congruent, or the two triangles, I should say, are congruent. And you have to say why. It's not SSS this time, it's SAS. So we need to actually say that. Pause here if you need to copy that down while I move on to the next one. Now, the other one we're doing is HL. HL is special for just right triangles, and you'll see why, because it stands for hypotenuse leg. Well, those things only occur in right triangles, so duh, you can only use the right triangles. Don't use them for non-right triangles. You're coming with stuff out of thin air then. Alright, if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two are congruent, hence HL. And again, it's only for right triangles. They get special privileges with this one. Alright, and if you forget, we have a handy dandy little picture up here that tells you that the hypotenuse is the one across from the 90-degree angle. Remember that 90 is that little box right there? It's always across from the 90. That's the hypotenuse. Alright, so on these ones, here's my hypotenuse, and hypotenuse. Alright, so those two have to be equal to each other, and let's say that this is the leg that's congruent. I could have picked these ones. Okay, but I only need one leg. Doesn't matter which leg, as long as it's congruent in both. I just picked the bottom one because I wanted to. But it has to be one leg, one hypotenuse. What's kind of nice about that is that you don't need another angle. You really just are looking at two sides. So it's less to look for. Alright, so take a look at this. Let's see if HL works for this one. It does not work for every right triangle, so don't go start using it like crazy. Just look for where it works. Alright, we've got that WY is congruent to XZ. Alright, so WY is here, XZ is here. Alright, now it's kind of hard to mark them as congruent because they cross. So I'm just going to keep them as red and mark them there. But just know it's this entire length, not just this little piece right here. Okay, it's the whole thing that I'm talking about is congruent. Okay, so this and this, I'll draw it again, we've got all scribbling. That's done. These symbols, hopefully in your brain you're thinking of what they are. They're an upside down T, they're the timeout symbol. They are perpendicular. Hopefully that's not drawing a blank in your brain as to what that means. It means that they intersect at 90 degrees. Memorize that if you have not already. That's really, really important. We told you that would come back to haunt you. So many things are coming back to haunt you today. So if they're perpendicular, if they intersect at 90 degrees, when WZ crosses ZY, I'll do that in a different color. So WZ crosses with ZY, That's going to make a 90 degree right there, so I can mark that up. And I'm actually going to put that on my thing down here. WZY equals 90 because perpendicular. And then it tells me X, Z, and ZY cross at 90. So they're a right angle as well. So angle X, Y, Z is 90 because it's perpendicular. Well, if they're both 90, duh, they equal each other. So let's say that they're equal. Alright, so I've got right triangles, which means I could use my hypotenuse leg. Alright, well, do I have hypotenuse or leg at all yet? Well, as a matter of fact, I do. If I look at just this triangle right here, okay, my 90 is right here, and if I go across here, there's my hypotenuse, and look at, there's this little line that we drew in earlier. So the hypotenuse are equal on both of them. They're both right triangles. Now we need a leg that's the same. Okay, we'll take a look at our picture. Is there anything that's overlapping? Why, yes, there is. As a matter of fact, ZY on the bottom is the same in both triangles. We use this almost every time, I think. It's because it's so popular. If it's in both triangles, it's congruent in both triangles. It's the same in both triangles because it's reflexive. So now we have our hypotenuse. This one was the leg. The hypotenuse was given to us up here, which means our triangles are congruent by, not SAS, not SSS, but by HL, which stands for hypotenuse leg. Go ahead and pause to copy that down if necessary. Alright, and the last one we're going to do is this one. Yes, I think it's the last one. Yes, it is. Alright, so the last one we're going to do, we're going to have to decide which one works. Okay, we've learned SAS, we've learned HL, now we got to use our brains to figure out which one actually works for this one. Alright, they tell us this perpendicular symbol again. So I'm going to abbreviate it PERP for perpendicular. That means it's going to cross at 90 degrees. So I'm going to mark it up on my picture because it tells me BD and AC are perpendicular. That means both of those are 90. Alright? I'm going to mark that out here. I just figured that out with my smartness, so I'm going to write it out. BDC, because perpendicular. And the smartboard's a little wonky, so if it looks a little crooked, it's not my fault. I'm sorry about that. Alright, so I've got that they're congruent because they're perpendicular, so they're both 90 degrees. Got to give a little bit of explanation there. It also tells me that BD bisects AC. Alright, so far I've got 90 degrees. I could use my HL. Let's see if it'll actually work though. Right now I'm not getting any of my hypotenuse told to me, so we'll hold off on that. Let's see what this bisecting thing does for us. Remember, bisect means to cut into two equal halves. Alright, so if BD bisects AC, right here, that means that this half equals this half. Alright, well that means AD is congruent, oopsies, is congruent to DC, and that is by definition of bisect. Okay, well let's take a look here, use our brains. Can we do HL? Well, I have a leg of each of them. I don't have any way to figure out the hypotenuse. The only thing I can see is that I've got an overlap right here, which means BD is congruent to BD by the reflexive property. Alright, well let's take a look at what I have. I have a side, I have an angle, and then I have side. Well, that means that I must have proven it by SAS. So it's not HL this time, even though it's a right triangle. That's okay. This time it is by SAS.